everyone, myself Savin from Triple T Academy. In this video, I'm solving Dcet 2014 paper questions from properties of solids and liquid chapters. Very first, I'm going to start with a question for liquids which do not wet a surface and the angle of contact is dash. Here we have different options. Lies between 0 degree and 90 degree, nearly 0 degree, lies between 90 degree and 180 degree, and nearly 90 degree. Here the concept is the liquid which do not wet a surface. Then the angle of contact. What is the angle of contact? This is the very first things we should know about it. The angle of contact is nothing but it is a tangent drawn to a liquid surface and the solid surface within the liquid. Suppose you can observe here liquid droplets are there, in which bottom is a solid surface. You can consider like that. Suppose in this solid surface and liquid particle, which this liquid droplet which do not wet a solid surface. So similarly, we can observe in this screen also. This we can consider as a liquid drop. This is a liquid drop, and here also in which the liquid drop is completely wet the solid surface. Completely wet the solid surface. So the reason the angle of contact is 0 degree here. The angle of contact, that means theta equal to 0 degree. If the partially wetted means, then you can observe here the angle is less than 90 degree. Suppose if you are going to consider this is a 0 degree here, then we can consider this is a 90 degree. So that means that the angle of contact, the tangent drawn with respect to solid surface and liquid drop. So therefore, what happen here is the angle is less than 90 degree. That is, if wet the glass, wet the solid surface. Then if it is does not wet means the angle is more than 90 degree. Just you can observe here. Suppose this is a 90 degree here. Then this surface here it will be a 0 degree, and this is a solid surface, and this is a liquid, liquid drop. So the reason you can observe here, from here to here, the angle is that is more than 90 degree. That is more than 90 degree. So here the question, the liquid is do not wet a surface and the angle of contact which we are going to represent by a letter theta. That angle of contact theta equal to dash. So for a which do not wet means, that means the angle more than 90 degree. That means obtuse angle. The more than 90 degree, but it is should be between a horizontal. That means horizontal means nothing but that is 180 degree. So in between 90 and 180 in this range, in here to here, this range, that is angle which should not be taken. So for question number 1, C is a right answer. C is a right answer. So that is a concept with respect to angle of contact. The same thing we can observe here also. It means that the angle of contact is measure the ability of a liquid to wet a solid surface. Wet the surface of solids. So with this angle of contact majorly depends upon a surface tension of a liquid, and at the same time nature of the surface. This is solid surface, which type of surface, in that also it majorly depends. Next, I'll proceed with the question number 2. That is, the force exerted by the liquid molecules per unit area on the surface is curved. Here the question, force per unit area, force exerted by the liquid molecules per unit area on the surface is curved. We have 4 options. Option number A, power, thrust, energy, pressure. Very first, what is the meaning of power? The power nothing but we know that that is a capacity to do work. That is a capacity to do work. Capacity to do work. So even if you come into the thrust, that is an axial force. That is a axial force that we can consider as a thrust. And energy nothing but it is a again this also you can go with that ability to do work. Ability to do work. Nothing but here observe here the question is force exerted by the liquid molecule per unit area. Nothing but force F, that I can consider as a force divided by area. Force by area. That is what? That is we can consider as a pressure. So pressure nothing but force by unit area. That usually we are going to denote by a letter P. P. So nothing but dear students. So observing all options A, B, C, and D, D is a right option. And at the same time, for our knowledge, we have to know about its unit also. So pressure is a ratio of force per unit area. I mean force exerted by the liquid molecule per unit area on a surface is called pressure. So therefore, the force is in usually we are going to denote by unit, that is Newton. And in area we are going to measure by in meter square or millimeter square or centimeter square. I mean square of the unit. So finally, the force per unit area, pressure nothing but the pressure is, that is force F by A. The F is in Newton divided by A in meter square. Nothing but the unit of pressure is Newton per meter square. This 1 Newton per meter square we are going to express in 1 Pascal. So there's a scientist derived from he is given a statement Pascal law. Latest is his name only is considered as a Pascal unit of pressure. Pascal is a unit of pressure. That means here same thing we can express by 1 Pascal. 1 Pascal is equal to 1 Newton per meter square. That is a unit of pressure. Usually we are going to express as unit of pressure is, that is 1 PA. That means 1 Newton per meter square. So suppose if you are going to express in a 1 kilopascal, 1 kPa, nothing but 1 into 10 to the power of 3 Newton per meter square. This is another way. That means system of units. So majorly for question number 2, the force exerted by the liquid molecule per unit area on a surface is called pressure. So therefore the right option is D. Next, dear students, I'm going to start with the question number 3. That is, diameter of rod is 4 centimeter and the stress acting on the rod is 640 dyne per centimeter square. Just observe here. Here diameter of a rod is given. Suppose if you consider this is a circular rod here. Then if you are going to apply a force on both ends, that is F. Then the area of a rod. Suppose if you consider this is a circular rod, that area we need to find. Before that, the diameter of the rod that is given, diameter D. Therefore, D equal to 4 centimeter. And stress acting on the rod is, stress means sigma. We are usually denoted by letter sigma. That is 640 dynes per centimeter square. Dyne per centimeter square. So this meaning here, dear students, we need to find a force acting on the rod. We have 4 options. Before that, we need to know about a stress. What is a stress? So tensile stress nothing but it is a ratio of force per unit area. The tensile stress nothing but it is a ratio of force per unit area. That means stress we are going to denote it by letter sigma. So sigma equal to F by A, where A is for a area of a circular rod. That is a A here. That means area we can find by pi r square, or if you have a diameter means pi d square divided by 4. Here we have a diameter, that means 4 centimeter is a diameter. Then by using this formula, that means the area of a circular rod equal to pi d square divided by 4. By using this formula, we can find the area of a circular rod. That means pi into, what is diameter? Diameter 4 given. So that means 4 square divided by 4. Next, pi into this 4 square we can write 4 into 4 divided by 4. Then this 4 get cancelled. Therefore, finally area is equal to pi 4 centimeter square. Pi 4 centimeter square. That is the area of a circular rod. Then the stress is given. That is 640 dyne per centimeter square. Here I'm going to convert. That means stress F is equal sigma equal to F by A. Or else I want to find a value of force. My aim is to find force acting on a rod is dash. That is our aim. That means F we need to find. Just this F we need to find. Then this A you can send to that side. If you send like that, then stress into area equal to force. Therefore, force is equal to, what is the value of stress? The stress is 640 dynes per centimeter square into area. What is area? That is pi into 4 centimeter square. So finally, dear students, this centimeter square get cancelled. The left, that is F is equal to, F means force equal to 640 into 4 into pi dynes. That means you can observe in our options. The 640 into 4, 642 is 1280. That 2 is 2560. Therefore, F is equal to 2560 pi. Pi keep it same thing. Okay. That dynes per is a force acting on the rod is 2560 pi dynes. That means for question number 3, B is a right answer. B is the right answer. I hope you agree with this and clear this question. Next, dear students, I'll proceed with the question number 4. That is, the molecular force of attraction in solid is. Just observe here, molecular force of attraction. Molecular force, that means attraction between one molecule to another molecule. In solid is dash. See, majorly the matters we are going to distinguish into 3 categories majorly. That is the first one. Suppose we can express in a solid, liquids, and gases. This is a distinguish the matters. That means suppose the solid substance, liquid substance, and gases. If we know the difference between all these 3, we can easily answer to this question. Here, the solid nothing but it having a rigid in shape, as well as rigid particles are attracting each other, as well as fixed shape and fixed volume. That means we can observe here the all particles are rigidly bonded together. We can observe in this diagram. And next, which having a fixed shape as well as fixed volume. And if we come into the second one, that is a liquid concept, in which dear students, we can observe here as compared to solids, the liquids have some free spaces there. That means in between the one molecule of the bottom, suppose liquid molecule, and another liquid molecule, it has some amount of space, and lesser intermolecular space in between intermolecular force of attraction in liquid as comparing with the solids. And these liquids are not rigid and do not have fixed shape, but it has a volume. Just you can observe here, suppose if you pour a liquid from one bowl to another bowl, it will take the bowl shape, and from that to any glass, it will take glass shape. That means that it has a specific volume, but there is no shape. That is a property of a liquid. Next, suppose if we consider the gases, we can compress it, and all the molecules in a gases are freely spaces. So the reason we can compress it and the molecular forces between one molecule of a gas to the another molecules are very less. So you can compress it in a majorly, so as comparing with the liquids as well as solids. So in case of gases, dear students, which do not have any fixed shape as well as volume also. There is no shape and there is no volume. Now observing all these starts from solids and liquids and coming to the gases. The solids have force of attraction more. Solids having more force of attraction, and nothing but by observing the option A, B, C, D, molecular force of attraction in solid is strong. So for question number 4, the option is right option is that is A. A is a right option for question number 4. Next, dear students, I'm going to proceed with the question number 5. The steel bars are used in the construction of bridges because of here there are different options: high plasticity due to high reflective index, or due to low density and high elasticity. Before going to select a right option, I'm going to give some information about steel. Steel material. The steel having an important property, because of its desirable property, we are going to use for a construction field. Majorly, it having high tensile strength, bond strength, and ductility. Ductility nothing but it is a property of material by virtue of which is drawn into thin wires. I mean, before fracture takes place, some expansion taking place. After some of the elongation, it may get break. So then, even though it having the ability to bend also, even though we can we can weld it that for the purpose we can use for a structural application, and even though it has a fire resistance. So this are the some of the example we can bridge in the given figure you can observe here. So for this desirable important property, because of this property, we are going to use steel in a structural member as a structural member for constructing a bridges and all. And at the same time, dear students, we should know about the steel major properties. Suppose the Poisson's ratio of steel. Poisson's ratio nothing but it is the ratio of lateral strain by linear strain. I explained in the previous video properly. That means the Poisson's ratio is lateral strain by linear strain. This having a value of 0.27 to 0.33. Approximately, we are going to consider this is 0.3. That is a 0.3 is a Poisson's ratio values of steel, and density nothing but a majorly we should know about mass per unit volume. The density that we are going to denote by a letter rho. The density of steel is, this is all values we are writing for a specifically for steel material. The density of steel is for around 7,850 kg per meter cube. That means it's up equal to 7.85 gram per centimeter cube. Next, Young's modulus. Young's modulus nothing but it is a linear strain by linear stress by linear strain, or linear stress by longitudinal strain, or direct stress by direct strain. That is Young's modulus. This Young's modulus of steel having highest value, that means approximately equal to 200 GPa. 200 GPa. 200 GPa nothing but 200 into 10 to the power of 9. 200 into 10 to the power of 9 Newton per meter square. 1 Pascal, we know that 1 Pascal nothing but a 1 Newton per meter square. So here G which is expressed 10 to the power of 9. Next, rigidity modulus is approximately equal to 80 GPa. 80 GPa. Nothing but 80 into 10 to the power of 9 Newton per meter square. Next, dear students, we can observe here by observing all these properties. It is a ductile material and weldability, and even though it having highest tensile strength. Due to this, by observing all the option A, B, C, and D, the D which having highest elasticity. So the reason it is ductile material as well as even though tensile strength is more. So due to its high elastic property, elastic strength, so we can use this material, this steel, for construction of a bridges and other constructional field. For question number 5, D is the right options. Next, dear students, I'll proceed with the question number 6. The flow of liquid through a narrow tube do not depends on. See, it's majorly the flow of liquid through narrow tube. Suppose you can observe here, this is a tube. This is a tube. Narrow means that is a specific directed tube. The tube which having a length of L, and in which the liquid is flowing with a pressure P, and the tube radius I can consider as a radius is R, where radius is a half of that, that is radius R, and the liquid which flowing through it, which having a viscosity, that viscosity I'm going to express by a letter mu. So by observing all this, the flow of liquid through a narrow tube do not depends on. This flow of liquid we can express by using a Poisson's equation. Poisson's equation for a flow of liquid. That is, the equation is Q equal to pi P R to the power of 4 divided by 8 mu into L. See here, dear students, the Q nothing but that is flow rate. That is flow rate. The Q nothing but that is flow rate. Next, P. P is a pressure of liquid flowing in a pipeline, and R nothing but that is the radius of a pipeline or a flow line. Then mu is a fluid viscosity. Viscosity nothing but it is a property of liquid by virtue of its resist the moment of one layer of fluid over the another adjacent layer of fluid. That is viscosity. It depends upon a friction. It depends upon friction between the liquid surface, liquid particle, between the liquid particle. Then L is the length of the pipeline. What is the total length of the pipeline? By observing all these, by considering these things, we can find the which type of flow. Majorly we can observe here. One thing is, first one, the nature of flow. The nature of flow means S. You can observe here. That means here fluid viscosity. Is this viscous flow or non-viscous flow or ideal flow? And that depends upon nothing but this nature of flow is dependent. Yes. Next, coming to the material of the tube, it's we'll see. Next, coming to the length. Option C, the length of the tube is that the flow of liquid again depends upon the L. L is here. That also directly depends. That means inversely depend. Nothing but this also dependent. Next, radius of the tube. Yes, R is dependent here. That means this also. Here the question is the flow of liquid through a narrow tube does not depend. The word is does not depend. So the reason, the option, the material of the tube, this is does not depend on liquid flow. So therefore for question number 6, B is a right answer. B is a right answer for question number 6. Dear student, these are the questions they asked in the previous year, in the year of 2014 from properties of solids and liquid chapters.